Hello Chem 1A, this is Chapter 1, Lecture Video 2, and in this lecture video we're going to be discussing matter. Alright, so chemistry is really the study of matter and its properties. That's what chemistry is focused on. Now, that's kind of a very, very broad study because everything is made up of matter, and so basically the chemistry can be the study of any object, substance, what have you. Matter is defined as anything that occupies space and has mass. And mass is the amount of matter an object contains. So we can classify matter into two different ways: by physical state, such as gas, liquid, or solid, or by its composition. What is the matter made up of? Is it made up of elements, compounds, or is it a mixture of more than one substance? So these are the two major ways chemists classify matter. Now we're going to go into these ways just a little bit more as we go through. Primarily in this class at this low of a level, we're only going to be talking about these three different physical states. There are more physical states out there, like plasma, for instance, but the three most common physical states are gas, liquid, solid, and you should have some feel for what they're all about. So let's talk about solids. Solids have a definite shape, meaning their shape isn't changing based on where they are or what container they're in. They have a definite volume. Their volume's also not changing based on other conditions around them. A rock is going to have the same volume unless I make a physical change to it by like hitting it with a sledgehammer. That would change its volume. But without any outside interference, the volume's not changing. We'll talk more about kinetic energy later, but solids have the lowest amount of kinetic energy, and what that really means is they don't move around very much. Solid particles tend to only vibrate back and forth just a tiny, tiny little bit. We can't feel it with our senses because our sense of touch is not that sensitive, but solids are all vibrating. Just very little, not much. Because of that, they do have some amount of kinetic energy, but it's the lowest. I like to do gases next because gases are pretty much the exact opposite of solids. They do not have a definite shape. Their shape is indefinite. What that means is the gas will take on whatever shape the container it's in is. So if I put a gas into a sphere, it'll take on the shape of a sphere. If I put a gas and put it into a cubic rectangle container, it'll take on the shape of a cubic rectangle. So whatever shape the container is, that's the shape of our gas. Gases also have indefinite volume. They can be compressed or expanded, and they will do that to fill whatever volume is available in the container they're in. Gases have the highest amount of kinetic energy. Gases are in constant, continuous motion. They're moving around all the time and quite fast as well. Liquids are kind of the middle ground between the two extremes, solid and gas. They have indefinite shape like gases, so liquids, as I'm sure you know, will take on whatever shape their container is that they're in, right? So if we pour water into one container, pour it into a different shaped container, it'll take on whatever the shape of the container it's in. Liquids, unlike gases, but like solids, have a definite volume. One of the stories I always share about this is if you're a car guy, my buddy, he one time installed a cold air intake on the bottom of his off-road vehicle, which if you're a car person, you know that is a horrible idea. He then took it off-roading, went through a lake, or I'm sorry, a river, a stream, and the cold air intake sucked up all that water and put it into the engine cylinder. And liquids don't compress. So what happened is the piston moved up inside the car's engine and it hit that water instead of a gas and couldn't compress it. And he basically destroyed his engine in his car. It was a brand new Jeep too. But this is a perfect example of how liquids do not compress or expand. Liquids are kind of the intermediate kinetic energy point, right? So they don't move around as much as gases, but they move around way more than solids. They move past each other very slowly. in a liquid, the particles. So they do have an intermediate amount of kinetic energy. And so here's a picture of bromine in all three of these physical states, right? So this cruddy kind of orangish color here is the solid. The liquid here looks black, but it's actually like this orange color here, and it's just so dark when you look through it and take a picture of it. The gas is also orange, so we have orange gas in this container, and that's why it's all orange in there. So it's kind of neat. Bromine's super toxic, but pretty. All right, so let's talk about classifying matter in terms of composition. So again, matter is anything that occupies space and has mass. We can split it up initially into two different groups, pure substances and mixtures. A pure substance has a fixed composition. It cannot be purified further. It's just one substance by itself, like pure water. Water is a compound. If we have a pure sample of water, then there's no other substances present. Mixtures, on the other hand, are made up of more than one substance. So we took two pure substances, we put them together, now we have a mixture. We can separate mixtures physically into pure substances using physical properties. Pure substances can then be broken up into two other groups, elements and compounds. Elements are the simplest a substance can be and cannot be broken down further by chemical means. That's kind of a lie, but for this point, we're going to say that's what's true. Compounds are where we have one or more different elements attached to each other using chemical bonds, and they're held together in fixed ratios. We can chemically combine elements to make compounds, and we can chemically separate compounds back into the elements that make them up. Mixtures can be separated into two other groups as well, homogeneous mixtures and heterogeneous mixtures. And we'll talk more about these later. So again, pure substances has well-defined physical and chemical properties. Can be classified either as an element or a compound. Compounds are made up of two or more different elements, and that's a big deal. Elements consist of only one type of atom, and we'll talk a lot about atoms in the next chapter. They cannot be decomposed or further simplified by ordinary means, and that's true. Particles that make up pure substances are the atom. So if we have an element by itself, it's made up of atoms, and that's the smallest unit of an element that has all the same properties of that element. Or if it's a compound or an element, it could be either. Another type of particle is a molecule. This is the smallest unit of a pure substance that has all the properties of that substance. For instance, water is made up of molecules of H2O. Okay, so let's talk about homogeneous and heterogeneous mixtures. So homogeneous mixtures consist of two or more substances in the same physical state. This same physical state is almost a requirement if the mixture is going to be homogeneous, but it's not the only thing that needs to be true for a homogeneous mixture. Homogeneous mixtures are where the two substances we've mixed together are evenly distributed across the entire mixture. So if we look at this blue solution here, it looks blue throughout the entire thing, the same color blue throughout the entire mixture. This is because the two substances in it, probably copper 2 sulfate and water, are mixed evenly across each other. There's no spot of blue in one spot and clear in another spot. It's blue throughout the entire mixture. A heterogeneous mixture does not have a uniform composition. Its components, we can actually usually see them separated from each other. Like in this beaker here, we see that the yellow isn't evenly distributed across the entire solution or mixture. It has these pockets of yellow, and these two are not mixing well. Generally, that's a distinguishing characteristic of a heterogeneous mixture. However, for both mixtures, we can use physical separation processes like filtration, distillation, to separate the two substances that are together into pure substances again. All right, so let's just do some quick macroscopic objects and decide whether they're heterogeneous or homogeneous. Salt water. If you've ever seen a glass of salt water, it's clear. There's no visually distinguishing characteristics, so salt water would count as homogeneous. Urine, if you're peeing, right? Hopefully you don't have a heterogeneous mixture there, because if you do, then that would be not great. If you've ever had to pass a kidney stone, I'm sure you know what I'm talking about. I've never, luckily. So that's going to be homogeneous most of the time. A T-bone steak. There's the bone in the T-bone steak, so that's definitely going to be different from the meat. And even then, there's like a fillet side, which has more fat content than the other side. So these are all very different in terms of their mixtures, right? There's a varying amount of stuff, and it's not all spread evenly throughout the entire substance. So this would be a heterogeneous mixture. Gasoline, again, much like urine, you really don't want solid particulates in your gasoline. It can destroy your engine. So gasoline hopefully is homogeneous. If you're putting in gasoline that's heterogeneous, you might hurt your car. A Twinkie. A Twinkie, I don't know if you guys, I mean, they kind of discontinued them for a while, but you know, they're like that yellow cake with the cream filling on the inside. That cream filling is not spread evenly across the entire Twinkie. It'd be really sticky if it was. So heterogeneous. All right, so if you guys have any questions, as always, please don't hesitate to contact me via email or via my Zoom office hours.